All right, so everything seems up and running. Welcome. Today we're gonna try to solve another coding challenge under 40 minutes, hopefully. This stream is for entertainment purposes, and without further ado, let's go and see what we've got today. So problems. Pick one. Medium. All right. And looks like many people like it, so okay. Given an array of integers nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. So we have 1, 1, 2, 1, 1, k equal 3. So how many subarrays we can have in order to it's like a sliding window approach, I think. So output 2. 1, 1, 2, 1 and 1, 2, 1, 1. 0. And here we have 2 subarrays equal 2. I put 16. Yes, I would imagine. This guy, this guy, this guy, right? Again, sounds like dynamic programming, to be honest. So let's see. No, 2 pointers. All right. All right, let's switch to the whiteboard. I think I might have an idea how to solve it. Let's discuss this last example 3. So to me, it sounds like, so we have these 2, 2, 2, 1, 2, 2, 1, and another 3, 2. So we count how many elements are not odd, right? So in this case 3. And then find the k window. Once we hit the first element, let's say 0 odd element, we found the second one, 1 here. So the 2 equal k, right? The sum of them. So we stop, and then we count the number of non-odd numbers to either the end or the, let's say, another odd element. So let's say we have 1 and then 2, 2 here, right? So in this case we stop here. And then we move from this pointer to the next one, right? Like from this until we hit the next one. and then we count number of elements, let's say here, right, when we will move to the next one. So once we have set up like this, so how many combinations we have? You may have 0 from this side, all right, don't take any number here, then 3 subarrays immediately here, or we may take one element here, let's say these two, and then we have 3 different subarrays here, 2, 3 different, so it's like, right, so 0 it's 3, 1 is 3, we have 2 elements is 3 versions, 3 elements is 3, so the total is 12, right? Then we also have options when this is 0, right, and this is also 3 plus 3, and when both are zeros plus 1. That's how we came up with 16. So this is a simple formula. So we use 2 pointers, use 2 pointers to count even integers, right? Before first odd and after kth odd. Interesting, I already solved it. So I see some solution here. Alright, whatever. Let's remove this private part, we don't need it. We'll go to different solution now, and hopefully it's linear these days. Alright, so let's see, it's in T1 equals 0. In T2 equal 0. Then int need to have start equals 0 at the beginning, and int end, right? Which is equal to 0. So while and is less than num size, we do this. Num size and start num start %2 not equals 0, right? No. This is the general cycle. So here we go. So first count even numbers before first odd, right? We say while num start %2 equals 0, we cnt1 plus plus, right? All right. So cnt2 counts even before first, counts odd until k, counts even after kth, and before kth plus 1. Maybe we should also have int t equals 0, then return ct. Alright, so now we counted number of even before first. Alright, so now we need while cnt two less than k, and obviously so we stop at the odd, right? So we now we can just say that and equals to start and start plus plus, right? Here you say obviously and plus plus, so we move and, then we say if nums and %2 equals 1, right? So here I'm using explicit to clearly say it's odd or even. Let's say cnt2 plus plus, right? Int2 less than k, and obviously and less than size. We do this, all right? So can we overcalculate some numbers? So no, because the core part will be fixed, right? So once we move it, it's already different subarray. All right, so it's easy then. So now we need to count. So now we know that int2 equals k, right here. So now we need to count int3 So now our and, right, is so we added counter to the 2, and now it's k, and then we increased it. All right, then we can say and minus minus. Doesn't really matter. int2. So let's say reset pointers. int2 minus minus, right? Before resetting pointers, we need second count k odd numbers third count the numbers after and actually maybe we don't need this, right? We just need to do this once, and then we will have this number from the prior one. All right, so let's take it out of it. and just use it here, right? Because our CNT3 will be CNT1 for the next run. After key and before key plus 1 or and, right? So currently and points to the last odd number, so we don't need it here. Let's so far remove everything in terms of reset. So while and is less than num size and nums and equals 0, so it's even, right? We say n plus plus and CNG3 plus plus. So now we found this case plus 1. So we do first computation for CNT, right? CNT equals to CNT1 times CNT3 plus 1, right? Or should we just say, so wait a second, this is 3, this is 3, I think it looks like, because it can be 0 case, right? So it creates a sim, yeah, I think it's just this one. Plus CNT3, I guess. Alright. Because it's the case of CNT 0, then the number of CNT3s will give us number of combinations. This is combinations with these plus combination in CNT3 is 0. So, and plus 1, just to have the case window itself. This is number of subarrays we have. Once we have that, then CNT1 obviously equals to CNT3. CNT3 equals to 0. Start is plus plus, so we shift it to the next element. Currently, then we will reset and here, right? Or do we need to do this? This is the thing. So I think what we need to say is here just once, right? No, this is wrong. So the problem is the CNT1, right? It's not CNT3 because we're moving by one element, so we have no idea how much CNT, how much even numbers between first odd and second odd. So we every time need to recompute it. So yeah, I think that was correct. So we can just move it here backward. All right. So what do we do? So we first count before first odd, right? Alright, so we count from the beginning before we hit the first odd. Then we count number of k odds. This is into 2, right? And then once we have it, so AMP is to start. And now, once we count these numbers to this k plus 1 odd number or till the end, we count this third one, we compute the formula. Then I guess we just set it back to 0. And what about CNT2? Right, our AND either at the end or at the keys plus 1 once we hit it. So if it's at keys plus 1, then we just push start to the next one, right, to start count the elements. This is fine until we find the first one, right? Once we find the first one, we already know that our AND is at the kth element, correct? Yeah, so C2 less than K, then AND is equal to start, so we need to count it. But if CNT2 is already K, and we know that once we shift it by 1, our AND on the K plus 1, so we will find the next K, right? So it's, so once we hit the first odd number on the start pointer, our end pointer will be on K plus 1, so it will be the second kth element, which is fine, I would say. And so this should work theoretically. Maybe I don't see something here. Push start. So our end is always ahead of the start, just after this one, because we push it further than start. And yeah, eventually we'll end up at num size. Here we break, we count this, and this is plus equal to this. That's it. Let's see if it compiles. Like 30 minutes already this one. Oh man. So this one, I guess. So we should say that start less than num size and this one, then and is less than or whatever, and is less than this. All right. So now the code so shouldn't be the problem. This is weird. Alright, let's see out. Start. And total count. So here n is less than num size. This is weird. Right, let's see actually not the count, but case 3. So we should have 0 here, 1, 1, 1, and 0 here. So it's 1 combination over here. Then we move it by 1. Again, we don't count anything. So let's just into 1. And the same thing. Into 3. But we get just one iteration here, right? I wonder why don't we increase should I say that yeah, and is 4, and and should be 0, 1, 2, 3 actually, not 4. I wonder why. Okay, let me comment out this one just to check what the and is. So start is at 0, which makes sense because it's odd, so we skip this, so CNT remains 0, CNT 1. Then we go here, CNT 2 less than key, and equals start, so end is equal 0, 2, so we start increasing and until it says among size and CNT 2 less than k. This is what I said we should set n minus minus, right? No, this is correct. We should stay at 4, right? We should stay at 4. Oh, why it's not 5 then? Because the current element where we stand at 4 is also odd. So this is fine. So we should move technically to the next one. But we don't. So we should go this way, right? Now I see. So right, so we moved n to the next element, so to 4, but the problem with 4 is that it's so the last element is also odd, so we stop, right? So we don't increment the kth plot. I see, yes. So all we need to do is this. So we don't want to stay at kth element because we will start counting here, right, after the kth element. So we don't care about kth element or kth plus 1 element. So that's what we do. And then obviously this will work. So now we should see 2 lines here. No, still 1. Interesting. Interesting. Okay, it shouldn't be here. It should be, I guess, here. Now we should see 2 lines. So right, and the answer is correct now. Let's see where it breaks next. I would imagine the formula itself may be wrong. Output 4, expected 0. How on earth is 4? So what should happen is really, yeah, and is 3, right? Yes, and key break, because in this case we can stop because of the end constraint. So no more key element. Submit. Alright, we passed. Stupidly slow algorithm, but we did it. Hey, memory is great though. Oh man, it's like, so, oh, wait a second. Now it will be better. We also can make, it's already constant, right? Yes, sir. That much better now. The memory complexity is much better now. So last time we haven't solved it, this time we solved it. With super weird while cycles and pointers, counters. Ugh. Logic is crazy here. But you saw the reasoning on the whiteboard, right? So let's submit a few more times to see what's the best course we can get. We did everything under 40 minutes, and I would say I'm fine with this course. I think this is one of the best. 93 for time complexity and 90 for space complexity. So let's switch back to the whiteboard. And, oh man, so it's 93. Which is not bad for medium problem under 40 minutes. It means we found the optimal algorithm, most likely, or at least close to optimal. So in this case, the complexity is technically linear, and space complexity is constant because we don't store anything except few pointers. And memory is 90. So auto is 183. Interesting. So it's again the same. I'm not sure if I can draw it, but this looks like they're thinking like what the heck is going on. Or maybe it's not clear. Let's add some head here. Like Simpson style. Alright, maybe it's better, maybe it's not. I don't like actually this one. So it looks like oh man, I suck at drawing stuff. Right. I think this is maybe still a little bit here. Make it more smooth, like the oh yeah, nice. Here we talking. All right. So maybe also fix this border slightly. Yeah. Here we go. So this is better. All right. See you tomorrow.